What's going on, guys? In today's video, we'll be going over everything you need to master context engineering. So just give us a quick rundown about context engineering. So providing context to an AI model is literally the difference maker between getting outputs that are actually personalized to your situation versus getting generic AI stuff that just sounds like shit, okay? When you don't give an AI any context about your business, your voice, or what you're trying to accomplish, it just guesses because these AI models are trained off of the entire internet. Okay, it cannot read your mind and know exactly what you want or know your exact voice or anything about your business, right? You have to provide the AI model that information. When you feed it the right information, everything changes. Your outputs actually start sounding like you, and you actually start solving your real problem like the way you want it to. And obviously, as a result, context is one of the biggest factors when implementing AI systems. And for me personally, most of the time spent on a system design is focused on how do we get the right context at the right time based off of the user's input. And also, most of prompt engineering is really just learning how to provide context effectively. So the first thing that we're gonna go over is static versus dynamic context, okay? So let's get into this. So let's use a content generation system as an example to break this down. Say you have a system where someone puts in a headline and some context about what they want this thread to be about, and it spits out a Twitter thread. So you give it a headline, let's say like how to lose weight in 30 days, and just some context on like how said person would lose weight in 30 days, right? And the AI will just write a full Twitter thread based off that, okay? When building an AI system like this, there are two types of context you need to think about. And again, this applies to any AI system, but it's static and dynamic. So static context is stuff that never changes no matter what the user asks for. So this includes things like your brand voice guidelines, audience research, copywriting frameworks, basically anything that should stay consistent across every piece of content you write for the specific situation, okay? So let's say it's a customer support chatbot, right? So this would be information on your product, information about how customer support frameworks, like how you actually want the AI to respond, like all that shit will stay the same no matter what question is being asked, right? So dynamic context though, dynamic context changes based on what the user is actually asking for or putting in as input. So here's where most people mess up. Where a lot of people fuck up is they treat dynamic context as static context and just dump everything they have into the prompt on every run. So the example I see all the time is if someone wants to write a thread about losing weight, they'll paste in 30 fitness threads as examples, but 90% of them are semi-related but not directly related to losing weight. So what you actually want to do is provide 3 to 4 threads, let's say, that performed well in the past, right? And are actually similar to what they're trying to write about. So you want to provide threads about losing weight, right? So if you want to write about losing weight, give the AI examples of your best performing threads about losing weight, not random threads about lifting heavy or like back pain, let's say, right? Because yes, they're related to fitness, but they're not related to losing weight. So all you end up doing is just overloading this prompt with just a shit ton of context that's not even relevant to the task you're trying to do. Because the example I like to always give is imagine when you're providing context is you're providing content for a dipshit intern. What would this intern need to have to actually perform this task efficiently and correctly? Like, yeah, would like your other threads about lifting heavy or back pain may help, sure, but is it gonna be like, is that the highest needle moving thing that you can give to that specific intern, let's say? Is that the highest needle moving thing that you can give to that intern to help them write a thread about losing weight? No, it's providing them threads about losing weight, right? So, and I'm gonna get into how we actually provide dynamic context. I'm just giving you guys an understanding of just like the differences between static and dynamic context, okay? So yeah, the key with dynamic context is you want to give the AI the most relevant examples based on the specific input that's being made. Again, providing the right context at the right time, okay? So another example is for a customer support bot. You don't want to give it every single SOP, your call scripts, Slack history. That's just too much shit, right? If the question's about onboarding, the thing I'd give the LLM would be an SOP for your onboarding. Similar questions clients have asked in the past along with the answers that you provided them, okay? Maybe also that would be very important is relevant info on the client itself. When did they join? What's their company about? And why this is considered dynamic context is because, again, this will change based on if a different client is asking this question. So if a different client is asking this question, we will change the client info that's being provided here, right? Or if it's the same client, this will change if that same client asks a different type of question. Like let's say they ask, how do I upgrade to an enterprise plan? I would obviously you would want to provide the LLM or even the dipshit intern here not the SOP on onboarding, but the SOP on like upsells and shit like that, right? And obviously, along with that too, you would provide them a different set of example questions because you don't want to provide them example questions that you've answered about onboarding. You want to provide them example questions about, say, upselling them. So again, providing static context is quite simple actually, as again, you can just hard code this into the prompt. So the rest of this doc will actually be focused on incorporating dynamic context into an AI system. The step one of learning about dynamic context, it's embeddings and RAG. So an embedding is just a way of turning text into numbers. So embeddings are super important to learn if you want to get into AI. So embeddings, again, is a fancy way of turning a chunk of text into a set of numbers, specifically a long list of numbers that represent the meaning of that text. So think of it like this. Humans understand that how do I change my credit card and how can I update my payment info? They mean the similar shit, right? Even though the words are different, they do, in essence, mean very similar things. But computers don't naturally understand that the way we do, right? They don't really understand language. Like if you did a keyword matching, it's not going to work, right? They need to see that these sentences have the same meaning, and that's where these embeddings come in. When you run these set of texts, right, these texts right here, through an embedding model, each of these one by one, it will convert them into a list of numbers. So let's just say it becomes, let me just tweak this. How do I change my credit card? Becomes this list of numbers. How can I update my payment info? Becomes this list of numbers. In the real world, these lists of numbers are like thousands of numbers long, by the way. But for this example, we're just gonna keep it small. Just again, it's just a fucking demo. But notice how though that these numbers are similar. And the reason why these numbers are similar is because again, these texts mean the same shit. So the key part here to understand is since similar meanings produce similar numbers, we can use some math similarity functions to find texts that mean the same thing, right? And what I mean by that, let me break this down step by step. If someone asks, how do I update my billing info? The system then can turn that question into embedding, okay? How do I update my billing info? Turn that into an embedding, so like a list of numbers, kind of like this, right? We're gonna compare it to all our number text, our list of numbers of our content that we have stashed in a database, let's say. So let's say we have all our SOPs converted into these lists of numbers, right? So again, these SOPs can be related to billing, shipping, marketing, whatever, right? Through this similarity search using embeddings, right? Because again, we would have to find the list of numbers that are similar to how I update my billing info, right? It will find the actual text with the most similar numbers, which will be context related to billing, right? So now we have this context is related to billing. We can pull up that relevant information, dynamically inject it into the prompt, and thus answer the question properly, okay? And this is how AI systems automatically find the right context without you having to manually search through everything yourself, okay? So now instead of the AI guessing or giving generic answers, it actually pulls the right information based on what the user is actually asking for. And by the way, guys, this whole process of using embeddings to find relevant information, it's called RAG, okay? Or Retrieval Augmented Generation, but RAG is what I call it, okay? It's basically the standard way most chatbots and internal tools retrieve dynamic context that's relevant to the user input, which is literally what we're doing here, right? We're putting in a user puts in a question, how do I update my billing info? We turn it into this embedding, so again, this list of numbers. We find other lists of numbers that are similar to it. With those lists of numbers, they have its corresponding text, and those corresponding texts here in this case will be shit about billing info, right? And then we can throw that into the prompt so it knows how we go about billing. So going back to the content generation example, let's say you have 200 Twitter threads that you've written over the past year. Here's how this would work, okay? Step one. So it's step one, I call this data ingestion. You're gonna embed, so every single thread, we have 200 of these threads. We're gonna convert each thread into an embedding, so again, those listed numbers, and push them up into a vector database. And by the way, a vector database is just a way to store these lists of numbers because again, these embeddings are like thousands of numbers long. You don't store that in a fucking Google sheet. You have to have an actual, what they call a vector database to store each of these, okay, for retrieval. To store each of these, and these vector databases, they allow you to do that similarity search through them to find the most similar embeddings or similar texts, right? So anyways, back to step one. You embed each 200 of your past threads. So again, we're gonna have 200 embeddings now, one for each thread, and store them, okay? And this is just done once up front. Step two, a user then inputs a headline like 5 ways to lose weight without going to the gym. So this is what I want the thread to be about. The system, our AI system is gonna turn that headline, our AI system will turn that headline into an embedding. Again, those listed numbers. It's gonna compare that embedding, the headline's embedding, to all 200 of our pre-embedded threads. And what we can then do is pull the 3 threads with the most similar embeddings, which will be threads about weight loss. And now these 3 relevant threads get injected as an example for the prompt for the AI to learn how to write this new thread in our writing style based off a similar topic that we want to write about, okay? Because again, what we're trying to do is provide the right context at the right time. And if we want to write a thread about 5 ways to lose weight about going to the gym, I would probably want to provide 3 examples about losing weight without going to the gym, right? So now instead of you manually digging through 200 threads to find relevant examples or just dumping random threads as context, the system automatically pulls the relevant ones based on what you're trying to write about. The next method we're going to talk about now is categorization. So with retrieving dynamic context using embeddings, right, it will grab the most similar content based on the meaning, which is usually good for the most part, right? But sometimes it can mess up. Like for example, if a customer says, let's say again, we're working with a customer support chatbot, right? And they say in the ticket, my package never arrived and I need it ASAP because it's my sister's birthday and I want to surprise her with something special since she's going through a tough time lately and my birthday is really important, blah, 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 right? She just goes on a rant about birthdays and bullshit. The embedding search might get confused by the words like gift, birthday, and special moments and pull in concepts like gift wrapping services or birthday promotions that we may have instead of the shipping lost package information that they actually need, right? Because again, yes, this text is about like my package never arrived, but she also goes on a rant, which if you ever done customer support, customers spew a lot of bullshit all the time, right? She goes on a rant about like her sister's birthday and all this stuff. So with the advancement of AI models and larger context windows, sometimes retrieval isn't really necessary at all. For example, let's go back to the customer support bot, right? Someone makes an inquiry that they didn't get their package. Yeah, ideally, we're using embeddings to find the specific snippet on how we handle lost packages. But since we know this is a shipping problem, we can just provide our entire shipping documentation as context. For customer support, I say most docs for each topic aren't extremely long. Let's just say it's like 10, 15 pages. So we can just provide the whole doc. You get a much higher accuracy. And when I say accuracy rate, I mean the rate at which we're providing relevant context that's actually needed to answer the question. So now instead of having to find the exact piece of chunk of text in our entire documentation, the game is just now, what topic does this question cover, right? And how to do this is it's actually really fucking simple. It's step 1, you just give the LLM the user input along with a predefined list of categories. And you want to actually have this list of categories predefined, okay? That's super important. So shipping, billing, refunds, account management. You can have an other category too that would then just trigger like a human, that would just then trigger human intervention. But step 2 would then have the LLM tag which categories the question falls under, okay? And then from there on, once we get the tags, it's a simple if-else statement. If it's tagged as shipping, inject the shipping docs. If it's tagged under refunds, inject the refunds document. The key though is having these categories predefined, because if you don't do that, you risk formatting issues and inconsistent tagging, and this way you now get reliable context retrieval for a structured use case. Because again, instead of chancing that it finds the right chunk of text, now all we're doing is it's just a game of like, which type of ticket does this fall under? So when to use categorization versus embedding similarity search? I would say use categorization when you have clear, distinct topics and each category has a manageable amount of content. So like customer support would be a great example. Because again, these documents for each topic aren't extremely long. And these models like Claude and GPT are so good now, like it can handle all that and answer the question very accurately still. Embedding similarity search is good when you need to find specific nuanced matches from a large amount of unstructured data. So finding that, say, a good example of this would be finding the 3 most relevant threads from 200 plus past threads based on the topic and style. Because most likely you don't have all your threads categorized by like weight loss, lift, back pain, X, Y, and Z. Like it's not predefined like that. Unless you can go do that, and that might make your life easier, but no one's got time to do that shit, right? Another example is, let's say instead of your SOPs are like neatly organized, and this applies a lot with like larger companies, they just have a massive operation. They just have a giant operations manual or a company handbook that covers like everything, right? All in technically one PDF document. And there's not a clean way to like break it up. It's not a clean way to like break it up by section and topic. So instead you break it up into chunks of text. So let's say like every 1,000 words, and then you embed each of those those 1,000 word chunks, you embed them and push them up to a vector database. And then now we can just do the similarity search to find the exact sections that match the user's questions. Okay. The next way to provide context, and this is one I've actually been playing around with a lot, and it's been really helpful, is providing relevant training data. So this method is gonna be a little different from RAG or a categorization, because instead of just providing reference context, you're giving the AI examples of transformations with feedback/explanations. So let's go back to the content generation example. So I've had a lot of content agencies and even sales agencies ask me kind of similar questions, but like they've told me like, hey, we have all these content reviews where our team gives a thread, then we reformat it and we give feedback on why this new version is better. So what do we have? And they have this data like semi-structured, right? They were able to make a Google sheet with like say the original thread, the improved thread, so the before and after, and the corresponding feedback on why this new version is better. And this is incredibly valuable training data for an LLM as it's writing a thread. And the reason why is because, one, it understands the before and after. It can understand what to do and what not to do because we have the feedback too. So we're giving it really nuanced explanations of like what we like and more importantly, what we don't like when writing a thread, right? So here's how I do this. So you take each content review. So each content review, again, has an original thread, the improved thread, and the feedback, right? And we embed just the original thread, okay? So again, we're turning this original thread, right, into an embedding, this own list of numbers. We're gonna store these embeddings along with their corresponding versions and feedback, okay? And when someone submits a headline and context for generating a new thread, the system will find similar original threads from our past reviews that relate to the same topic. Let's say if someone submits how to lose weight in 30 days without going to the gym. We're gonna find similar threads, we're gonna find similar content reviews that we've done in the past about losing weight without going to the gym, right? And we can inject that into the prompt. So what we've thrown in the prompt is the original thread, so the before, what the thread turned into, along with feedback on why we changed it to this way. And now what's happening, this is going to improve the AI because those similar before and after examples, when generating the new thread, it'll now understand the specific nuances of what you're looking for when writing this topic. And in my opinion, doing this is really what gets you like that top, like that, like extra, because like with all this other stuff, when providing like your brand voice guidelines, your market research, your past examples, like that gets you like 90% there. Doing this gets you like that extra 5% nudge that just really makes it good, I would say. But yeah, nonetheless, this method works really well when you actually have the data for it. I would say most people don't have this data structured in a nice clean like Google sheet, let's say, or a CSV file where it's like one column's your original thread, second column's your improved thereafter. Then the second column is the improved thread, and then third column is an explanation or like feedback on why this new version is better. Most people don't have this for like say content or even like say sales call reviews or email reviews. But if you do have this stored, right, you can use this for sales call reviews. Like you embed the objection handling section from all your past sales calls with your feedback on what can be improved, or email reviews, same thing, and client proposals, right? And the key is just having a substantial amount of information of examples so that AI can learn your specific standards, your preferences, and your nuances. And also too, if you really want to do this approach, I would highly recommend using AI to extract this data, right? Because the way that I suggested for this content agency to extract all this data, this content agency would actually have their employees submit the threads that they wrote into say a Slack channel, and then they would reply back with an improved version and feedback, okay? So it was actually like, it still required manual work. Like data collection at the end of the day is always gonna be a lot of manual work. Like it's like the most painful part, in my opinion, when building AI systems. But we were able to pull in the Slack convos and then extract them all out. It's like, hey, grab this thread, grab the improved thread, X, Y, and Z, and here's what it looks like. So you can use AI to help you do that. But nonetheless, doing this will require some level of effort to extract and get this structured data. But yeah, guys, that is pretty much it. These are just some of the ways of like how I provide dynamic context into my AI systems overall. And again, this is more so applied when you're building like an actual deployed AI system, like an actual internal tool or like something that's like user facing. Like you don't really like, when you're working with say like just Claude or ChatGPT on the interface, like you're just copy and pasting shit, right? Like, so it's not, you don't really need all this stuff. Like technically it is dynamic context because it may change based off what you need. But this is more so applicable when you're building an actual deployed AI system. And notice too how in this doc, I don't really talk about like prompt structuring or like JSON prompting or like XML prompting and shit like that. Like, yes, that stuff helps, right? But guys, when it comes to context engineering, and from my personal experience, like those things help. The highest leverage thing that you can do when providing context into an LLM is being able to provide the most relevant context at the right time. Okay, like yes, the way you structure like the JSON or the XML prompt can help it a little bit and like help it be more organized and clean, right? But that's just not gonna work if you're just info dumping everything, right? If you're info dumping 30 threads to write a single thread about weight loss, right? Like that prompt structure isn't gonna change the fact that you're just overloading with context, or it's not going to change. It's not going to help the fact that you're not providing the correct context to say answering the customer support ticket, right? Guys, to give you context on myself, like most of my prompts are just plain text prompts. I don't use any that much fancy like XML or JSON prompting. It's just plain text, and all my AI systems work fine. And the reason why is because I focus heavily on just making sure we're providing the right context at the right time. And that comes from understanding how embeddings work, understanding how to use LLMs to navigate which context we provide, using say categorization or using embeddings for RAG, or building a clean structured data set to provide relevant training data. These are the things that move the needle, and that's why I kind of primarily focused on this, because this is to me, if you want an 80-20 context engineering, This is what you need to focus on. Learning how to actually grab the most relevant context based off the specific input at that right time. Okay. But yeah, guys, that is the end of this video. Thank you guys so much and hope you guys have a great day.